Here I'm going to show you how substituted hydrocarbons are created from just regular hydrocarbons. I have two simplest hydrocarbons here, methane and ethane. In substituted hydrocarbons, we take one or several of the hydrogens from the hydrocarbon and we replace it with something else. It could be just a single atom, or it could be a group of atoms that is replacing the hydrogens. So for example, let's simulate the halogen family, or the substituted hydrocarbons with the halogen atoms. So for example, here we replace hydrogen with chlorine and we form chlormethane. Of course, the molecular formula of this would be C, and then we still have 3 hydrogens, so CH3, Cl. The Cl, the halogen, comes at the end. Here we have, we had ethane, so if we replace, for example, one of the hydrogens with fluorine, we get fluorethane, and the molecular formula would be, we have 2 carbons, so C2, H5, F. There will be fluorethane. Now let's look at alcohols. In alcohols, the hydrogens are replaced. With the hydroxyl group, which has an oxygen and a hydrogen in it. So here, right here, is alcohol made out of methane, which would be methanol. So this is methanol. You don't want to drink that; it's a poison. Here we have ethanol, okay, made out of ethane. So this is the second simplest alcohol. This is the one that is used in alcohol beverages. And don't kid yourself, this is also a poison. About 10 milliliters of methanol is poisonous. With ethanol, it's slightly more than that, but please don't drink. Okay, now let's look at the last functional group, which is the carboxyl group. Now the carboxyl group, which is sometimes written as this, COOH, the structure of it is actually, it goes like this. So this is the carboxyl group. There's a double bond between one carbon and an oxygen. So this is the molecular formula, I guess, for this functional group, for the carboxyl group. This is the structure. So let's use it on methane. Okay, here we have methane, and we actually have to take 3 of the hydrogens away to create the simplest organic acid. So there you see the carboxyl group. This is the formic acid or the antacid. If we do the same thing with ethane, we get the second simplest organic acid, which is called the acetic acid, which is basically vinegar. Vinegar that you use for cooking is just basically a dilute solution of usually 3% solution of this acetic acid, and with some other things added to it to give it a specific taste. There are very different, many different kinds of different vinegars. Then we have wine vinegar, and then you have apple vinegar, and different kind of vinegars with different herbs and stuff added to it. But this is the main component, the acetic acid, and here is the formic acid. There are many other different kinds of the functional groups in substituted hydrocarbons. Many groups of substituted hydrocarbons. We just deal with 3 of them: the halogen family, substituted hydrocarbons, the alcohols, and then the organic acids.